Hi everybody. I wanted to take a quick minute to show you how to think about the Cahn Ingold Prelog system of ranking substituents when we talk about stereochemistry. So if we take a molecule like this, and maybe we put chlorine here. First question would be, is this molecule chiral? And we'd look for the number of stereocenters, and we find that yes, it does have one stereocenter here. I like to make sure that I add on that fourth group just so that we can see it. And so in this case, we have a methyl group to the left of this carbon, a chlorine coming towards us, a hydrogen pointed away from us, and then an ethyl group off to the right. So the Cahn Ingold Prelog system is a mechanism for deciding which one of these groups has the first priority, second priority, third priority when we're testing for stereochemistry and looking for that absolute configuration. And it's completely based on the atomic number that we're going to see for each of these substituents. And so when we pull out our periodic table, we'll remember, of course, that hydrogen has an atomic number of 1. Chlorine has an atomic number of 17. The first thing that we run into going down the left branch is a carbon. It has an atomic number of 6. And of course, going to the right, if I clear this out just a little bit and make this ethyl group a little bit more specific, we're going to see that we run into a carbon as well right here with the number 6, atomic number 6. And so when we start talking about our rankings, we can say that our number 1 ranking is going to be chlorine with that highest atomic number at 17. Number 2 and number 3 we're going to have to work for, but we know that number 4 is going to be our hydrogen with that really small atomic number of 1. Now when we have a tie, as we do in the case of our number 2 and number 3 substituents, we've run into a carbon in both cases. Now we're going to go out one more step. So I'm going to go ahead and make this methyl group a little bit more explicit yet. So there's our carbon that we already ran into. Now we're going to go out to the next level here. And the same thing with this other methylene group. I'm going to expand that a little bit, because we already know that our carbons here left us tied. They both had an atomic number of 6. So now we look at the next step out. And what you'll do is you'll follow from that carbon, follow out all of its bonds to the highest ranked atom you can get to, the highest atomic number atom you can get to. And in this case, going on the left carbon, the methyl group, the highest thing that we can get to is a hydrogen, no matter what direction we go. That's atomic number 1. Whereas going out to the right along the ethyl group, we see that we can run into a carbon again, atomic number 6. And so that now acts as our tiebreaker to say that our higher of those 2 ranked substituents is our ethyl group, and our lower of the 2 ranked substituents is our methyl group. And so now what we see, if we redraw that chirality center, we can say we have our first ranked group here with chlorine. Our 4th ranked group is pointed away from us, which is what we'd like for this determination. Our 3rd ranked group is over here, and our 2nd ranked group is over there. And now it's just a matter of looking at the rotation. Once number 4 is pointed away from us, we look at the rotation from 1 to 2 to 3. We see what direction that is, and since that's clockwise, we'd say that's the R configuration. And so the name of this molecule overall would be R, and then its main name, which is 2-chlorobutane. If a problem was asking us now, once we know that, to draw the enantiomer of this, to draw its mirror image, or to name its mirror image, we can do that. So we would say the enantiomer would be called S2-chlorobutane, and it can be easily obtained by drawing the molecule in the same kind of orientation that it was in and just switching two of the groups. So we can put, for instance, instead of having our chlorine to the front, hydrogen to the back, we can put our hydrogen to the front, chlorine to the back. It's that simple. There are plenty of other ways that we could draw this molecule, but that's the easiest way to do it for sure. So with Cahn Ingold Prelog system, we just want to be sure that we are being careful about following to the highest ranked substituent along each branch. If we encounter a tie, then we go from that point and again look for the highest sort of next step out as we follow those paths. Practice makes perfect on this one. Good luck.